Okay, in this example, we're going to be doing a confidence interval. Let's see what it says. Early childhood development studies indicate that the more often a child is read to from birth, the earlier the child begins to read. A local parents group wants to test this and samples families with young children, finding the following results. Okay, so here we have started to read before age 4, started to read after age 4. So do you see what those sections are meaning? This is early, started early or late, right? After age or before age 4. Okay, and this is among, go up here to the top, this is among people read to at least 3 times per week. So I'll say read to often, read to fewer than 3 times, read to less often. Let's say read to less often, okay. Right? Okay, so they did this study, and they had a bunch of people. And so 52 kids who were read to often started reading early. 34 kids who were read to often started reading later, which is kind of the opposite of what they're saying. They're saying if you're read too often, like these people, should learn to read earlier. Over here, the kids that were read to less often, 35 still learned to read early anyway, and 52, it took them longer. Just looking at the data, it looks like it's true, right? Among the people that were read to more often, more of them learned to read earlier than later. Whereas among the kids that were read to less often, more of them learned to read later than those who learned to read early. All right, anyway, let's do the official 95% confidence interval to estimate the true difference between the proportions of children who read at an early age when read to frequently compared to those who read to less often. Okay, so how do we do a 95% confidence interval? True difference between proportions? Well, if we go to the notes, see if I can find them here. Here they are, your exam 4 notes. So here we have 2 proportions. You're either going to use the 2 proportion z test or the 2 proportion z interval. This is a confidence interval, not a hypothesis test, so we're going to use the 2 prop z interval for confidence interval. So 2 prop z interval. All right, so on our calculator then, whoops, I'm looking at the wrong problem, aren't I? There we go. We're going to go stat. Go over to tests and go down to, I think it's at B. Let me double check on my calculator here. Yeah, 2 prop z interval. I've done too many of these. I have the letters memorized. And I don't have a good memory, so that means I've done a lot of these. All right, 2 prop z interval, hit enter. And it'll ask you a bunch of questions. It'll say, okay, what is x1? What is n1? What is x2? What is n2? And what is the sea level? Okay, so x1, n1. So that's a little tricky. Remember, we're doing the 2 different populations. And it says population 1 is the frequently read to children. Read too often children, this group. This is population 1. And this over here, in fact, let me use a different color just for clarity. This over here is population number 2. This is population number 1 over here, and this population number 2 over there. Okay, so, right? So population 1 is the frequently read to. Population 2 is not frequently read to. Underline it with the same color. There we go. All right. So then, what am I going to do? Well, it wants to figure out the proportion of children who read at an early age. Proportion. What we're trying to find. Yeah, let me erase this right here. Is the proportion of children who read at an early age. Early, like this proportion. That proportion. In other words, 52 goes here. Let me go with the color theme. 52 goes here, and 35 goes there. But what's in the total? For the total, you're going to have to add these up. They're not giving us the total. That's probably the trick on this one. So this is N1, and over here we're going to have to add these up. What's that, 87? That's N2. So 86 and 87. See how we came up with that? N is always the total, isn't it? N in any statistics problem is always the total. So the total in sample 1 is 86. The total in sample 2 is 87. Well, so we actually use 52, the number that read early, out of 86. That's saying 52 out of 86 read early from population 1, and 35 out of 87 read early from population 2. So that's a little tricky. That's what those mean on your calculator. That's what we're talking about. So remember, the N's are the totals, and the X are the number that did what we want. In this case, read early, like they said right here, proportions who read early. All right, I'm going to put all that stuff in my calculator and see what happens. Confidence level is what? Oh, 95 right there. So I'll put that in, 0.95, and calculate. I'm getting an answer that my answer came out to be 0.05642, 05642, comma 0.34828. Now they want me to round it to 3 places, don't they? So it says right here 3 places, so 3 places, 3 places, so that's parenthesis 056, parenthesis 348. Okay, and so there it is. There's our confidence interval. Now, what does that mean? It says, according to your confidence interval, what? With 95% confidence, the proportion who start early is between 0.056 and 0.348? Yeah, that looks right. Oh, higher among children who read too frequently than those who read too less often. Is that right? Or with 95% confidence, the proportion of children who start reading by age 4 is between 0.05, those same numbers, lower, say higher, lower, among children who read too frequently. Or at 95%, our data is inconclusive. What's that? Which one is it? Well, this is all about the idea. This is often difficult for students to understand, but very important if you're going to understand what a confidence interval is really saying. You see, a confidence interval is a subtraction between two things, right? It's population, let me write it right over here. It's population 1 minus population 2. It says it right here. Population 1, right here, P1 minus P2. So if you subtract two things, and the answer, whoops, I'm kind of being scribbly there, and the answer comes out positive, that means P1 is bigger, right? The first number. If the answer is positive, it means it, right? Because if I go like 7 minus 5, that comes out positive too because the first number is bigger. You see? When you subtract two things and the answer is positive, that means the first one's bigger. If you subtract two things and you get an answer that's a negative, I'm not doing that very well, you get an answer that is negative, that means P2 is bigger. Now, there's just not room to write here, so I'm being kind of scribbly. P2 is bigger, right? Because if you subtract two things like 5 minus 7, that'll come out negative 2 because the second number's bigger. If the first number's bigger, it comes out positive. If the second number's bigger, it comes out negative. It means the second number's bigger. Now, and what did ours come out to be? Well, our confidence interval, let me put it down here, read down here. Our confidence interval, notice, is from positive 0.056 to positive 0.348. So what we're saying is we're 95% confident that the real answer is between, we're 95% confident that the average difference is between this number and that number. So if I tell you, let's look at a number line. Here's 0, here's 0.056, here's 0.348. If I say, hey, I'm 95% sure that the number I'm thinking of is between here and here. It's between 0.056 and, positive 0.056 and positive 0.348. Like maybe it's right there, right? It's somewhere in that interval between those two numbers, which means it's positive, right? If it's between two positive numbers, it's positive. So what does that mean if it's a positive number? Well, right here. When the answer is positive, that means the first number is bigger. Right? Because remember, this is a difference. This confidence interval, this is what confuses students. They get confused on what this means. This confidence interval is not just one number, it's the difference between two numbers. It's the answer to the difference between two numbers. We're saying we are 95% confident that the average difference between P1 and P2 is some number between 0.056 and 0.348, right? Which means it's positive. We're pretty sure, we're 95% sure, that if you subtract P1 minus P2, you're going to get some answer in this interval, which is between two positive numbers, is therefore positive. If you subtract two things to get positive, that means the first one was bigger. P1 is bigger. So P1's bigger. What's P1? Population 1, which is the ones that are read to more often, have a bigger rate of early reading. So, with 95% confidence, the proportion of children who start reading by age 4, between 0.05 and 0.6, higher among children who are read to frequently. Yeah, right? The P1 group is higher. That's what our data is saying. Does that make sense? If we had had a confidence interval that was negative, then it would have went the other way, right? Because if you get a negative answer, that means the second number is bigger. If you subtract two things, the answer comes out negative. If you had a negative confidence interval, that means the second one's bigger. And the other thing that can happen is you might have, I'll write it down here in a different color, hopefully. Sometimes you'll get, so there's three cases. There's case 1, which is what happened for us, that the confidence interval was positive. Case 2, you'll get a confidence interval where you have a negative number, and so that means negative answer, and so that means negative answer, P2 bigger. P2 is bigger, or you could say P1 is smaller, whatever way you want to say that. P1 is smaller. The number in the front is smaller, or the number at the back is bigger, same thing being said either way. And then the third case that can happen, might happen on your example, is that you can get a confidence interval that has a negative number and a positive number. See, we got two positives, and that means positive, so P1 is bigger. That was our conclusion. If you get two negative numbers, then P1 is smaller. The number in the front is smaller, the number in the back is bigger. But if you get one negative, one positive, what does that mean? The answer could be positive or negative, right? Because you're just saying it's from some negative number to some positive. You got 0 in between. So we don't know if we're saying it's an interval between a negative number and a positive number. So we don't know. The answer could be positive or negative. So in that case, we would say inconclusive. That's the inconclusive case where you can't be sure whether P1's bigger or P2's bigger. So does that make sense? We are talking about the subtraction. This is a difference between two groups. The difference between the group that was read to more often and less often. And the difference, if it comes out between two positive numbers, we're confident the real difference is between two positive numbers, and it must be positive, which means the number in the front is bigger. Right? If you subtract two numbers and it comes out positive, the number in the front is bigger. Whereas if it comes out negative confidence, both negative, that means the number in the front is smaller. The P2 in the back is bigger. Right? That's how you get a negative subtraction if the number in the front is smaller and the number in the back is bigger. And so that's the second case. And then the third case is right here. It's inconclusive. When you get one negative, one positive, the difference could be positive or negative. We don't know. It's inconclusive. Those are the three different cases. Spend time thinking on that. That's not